Hi then, everybody. Morgan here. We've got a few more problems to look at that are stoichiometry problems from the gas law lecture outline for AP. We are on page number 9. We're starting off here with a reaction where hydrogen chloride gas is produced by the decomposition of ammonium chloride. Now that reaction is NH4Cl to give you NH3 and HCl. How many liters of HCl can be produced by the reaction of 250.0 grams of ammonium chloride at STP? So we have 250.0 grams NH4Cl times, and this is going to get us into moles. So 1 mole of NH4Cl, it's got a molar mass of 53.49 on the periodic table I used. You might round off just a little bit differently, I wouldn't worry. 1 mole NH4Cl is a 1-to-1 ratio with the HCl from that balanced chemical equation. So that gives us 4.674 moles of the hydrogen chloride, HCl. Okay? Now, we've got STP again. So we can use our little shortcut, 4.674 moles HCl times, and we can use the 22.4 liters per mole. Mole is going to cancel. And on my calculator, that was 104.7 liters. Problem is, I'm looking at sig figs here, and 22.4 really is not a definition. Okay, that's something that's calculated, so I'm probably down to 3 sig figs, which would be about 105 liters of the HCl. Now, if I did it as a PV equal nRT, I could have had a few more sig figs in there and be all right with the 104.7. Okay. Now, let's go on. Look at a new reaction. Calcium hydride reacts with water to produce hydrogen gas. CaH2 plus H2O. That's going to give me CaOH sub 2 and H2. And to balance that out, I need a 2 there and a 2 there. Okay? Now, I want to produce 10 liters at 27 degrees and 740 torr. So N is PV over RT, which is going to be 740 torr. Now my volume for this is 10.0 liters. I'm going to use 62.4 liter torr per mole K. And then I'm at 27 plus 270. That's going to be 300. I'm at 300 Kelvin. Okay. Torr is gone. Liter. Kelvin. So this is 0.40 moles of H2. Now, my 0.40 moles of H2, okay, can be converted back to grams of calcium hydride. 1 mole of H2 is 2.02 grams of H2. And let's see, nope, actually this is going to be 2 moles of H2 downstairs and 1 mole CaH2 upstairs. And since I'm going all the way, you know what? I don't actually need that step. I'm sorry, folks. Let's just kind of get rid of that one. That's me being silly. Not looking at things carefully. moles to moles. And then I can say 1 mole of CaH2 at 42.10 grams of CaH2. And every time I make a mistake, it seems to be pointed out to me almost immediately by the units. So I'm kind of happy that happens sometimes. It shows you how important it is to keep track of the units. All right? So about 8.4 grams CaH2. Okay? So hopefully we're doing pretty good there. Okay? Now, for our next one, C2H2 gas was formed by the reaction of CaC2 plus H2O to give us that C2H2 and CaOH sub 2. I've never owned one of those miner's lamps. My grandfather had one, but he never actually showed me how it worked. I just remember it hanging in his workshop. Okay? But he had actually been a coal miner, so he had the right to use one of those. All right, so what volume of the C2H2 at temperature pressure? We reduced by 1.00 grams. 1.00 grams CaC2 times 1 mole CaC2, so 40 plus a couple for 2 times 12, 64.10 grams CaC2. Then 1 mole of the CaC2 is going to give us 1 mole of C2H2. That'll cancel out. That'll cancel out. 0.0156 moles C2H2. Okay? Now plug that into our PV equal nRT. This is not at STP. I can't use my little shortcut there. 0.0156 moles. All right, I'm in torr, so I'm going to use 62.4 liter torr per mole K. Temperature, 24, so that's going to be 297 Kelvin over my 755 torr. Okay, moles, torr, Kelvin. And that's going to leave me with 0.383 liters. And when a number is that small in terms of gases, I'd probably say 383 milliliters. Okay. I hope you did well on those. Not the hardest questions that you will ever see. We did some stuff like that last year, but they are important questions and ones that you are going to be tested on. Okay. Thanks for tuning in.